In just 9 minutes, let's leverage the ZeroDev SDK along with Particle's Wallet as a Service to create a smart account through social login and send transactions. So continuing down the series of exploring ERC 4337 account abstraction utilization with Particle's Wallet as a Service, today we're covering ZeroDev. ZeroDev essentially allows you to create smart accounts through things like social login with Wallet as a Service providers such as Particle, and of course within these smart accounts, do things like sponsor gas, batch transactions, use session keys, and even things like automating transactions. Now, for my time with ZeroDev, I have to say, the ZeroDev SDK is super easy and seamless to work with, especially when using our wallet as a service. Most major functions can be made in just 1 or 2 lines of code. So it's super easy to get started and create powerful ERC 4337 enabled experiences. So that's exactly why today, in just 9 minutes, we're going to explore utilization of Particle's Wallet as a Service, hand in hand with the ZeroDev SDK to create a smart account and send transactions. So let's jump right into it. So to set the stage here, essentially we're going to be building an application that leverages the ZeroDev SDK to initialize a smart account and then do 3 main functions. The first is that we'll do a single user operation. This will be a 0.001 ETH burn. The second, we'll do a batch user operation, which will be 2 of those burn transactions, batched together and sent. And then for the third, we'll transfer ownership of the smart account to a different address. This will only take about 100 lines of code. So let's jump right into it. To start, of course, we'll need to import a few different base libraries. That'll be React and use state as well as use effect. Additionally, we can import Particle Network. This is our sort of master configuration variable for Particle's Wallet as a Service. And that'll come from @particle-network/auth. Another important one here will be Particle Provider from @particle-network/provider. This is what we'll be using to initialize a smart account with the ZeroDev SDK. And speaking of the ZeroDev SDK, we can import ECDSA provider, get RPC provider owner, and that'll come from @ZeroDev/SDK. We can also import ethers and notification. Then finally, we can go ahead and throw in our CSS. Okay, so now with those initialized, let's move on to our configuration of Particle Network. This will be how we configure the social login and thus the owner address of the smart account that we'll create in a moment. We can save this in a variable called particle, which will be new Particle Network, and then we can open this up here. But before we define this, let's quickly head over to the Particle dashboard to retrieve our project ID, our client key, and our app ID. All right, so as you can see, we are now on the Particle dashboard. We can head over here and click Add New Project. I'll name this ZeroDev Demo and click Save. And here we'll need to spin up an application. In my case, I'm building a web app. I'll name this again ZeroDev Demo, and I can throw in the domain in which I'm hosting it right here. Although if you're running this on localhost, then you can just throw in any filler domain. So I'll click OK. Now with that there, we can copy the project ID, the client key, and the app ID. Let's now throw those into environment variables and move on. So we can set the project ID as process.env.react app project ID. We can do the same thing for the client key, and finally also for the app ID. Let's also go ahead and choose the chain. That'll be Ethereum. And for the chain ID, we can do 5 because this will be on Ethereum Go Early. Okay, so that is Particle initialized. With that done, we just have one more thing to do here before we open up the app. And that'll be doing let ECDSA provider, as we'll be redefining this later. Okay, so we can now move on to creating our main app component. This will contain all of our primary functions and of course the JSX for actually structuring the application. So we can name this app and open that up here. As usual, let's start by throwing in a few different states. That'll be user info, set user info. We can do the same thing for ETH balance, as well as for smart account. All right, so with those set, let's go ahead and open this up by doing a use effect. We'll be using this to initialize ECDSA provider, as well as fetch our account info. So within the use effect, let's first go ahead and open up init and fetch. That'll be asynchronous. And then in here, we can initialize provider, as well as call a function that we'll write in a minute. So let's start by checking if user info is defined. If it is defined, then that indicates that a user has now logged in. So if that returns true, then we can go ahead and set ECDSA provider to await ECDSA provider.init. Now, before we do this, we'll need to head over to the ZeroDev dashboard and grab our project ID. All right, so as you can see, I'm now on the ZeroDev dashboard. I already have a project built, but if you want to start a new one, you can head over here, click new project, and name it demo video. Then set the blockchain to Ethereum Go Early and create project. Okay, so now that I'm in here, what I'll do is copy the project ID. Then we can throw that into an environment variable here and set project ID to that environment variable. Okay, so now with that set, we can also set the owner, which will be get RPC provider owner, and then we can pass in new particle provider and particle.auth. And that's it. We've now set that up. All we have to do now is throw in and await fetch account info, which we'll define right now. But let's quickly close this off by doing init and fetch and throwing in user info right here. Okay, so let's go ahead and define fetch account info. This is what we'll be using to fetch the address as well as the balance of the smart account. So we can name this fetch account info, and we can start by retrieving the address. We can save this in a variable called address, and that'll be await ECDSA provider.get address. Then we can go ahead and set the smart account to that response, in this case address. Let's also go ahead and grab the balance. We can do this in a variable called balance, and we can wrap that in ethers.utils.format ether. And then in this case, we can push a JSON RPC get balance request directly to ECDSA provider. So let's do that with await ECDSA provider .request. We can set the method as eth_getBalance and the params to address and latest. And we can close this off by doing set ETH balance and throwing in balance. All right, so before we start building the core logic for actually executing the user operations and transferring account ownership, we just have one more function to make, which will be handle login. This is essentially what will power the social login side of our application. This function will take one parameter called preferred auth type, and it'll be super simple. We can just set one variable called user, and that'll be await particle.auth.login, and then we can pass in preferred auth type. Then finally, we can just do set user info and pass in user. Okay, so now let's move on to creating three main functions that I mentioned earlier. This will be execute user op, execute batch user ops, and change owner. Like I mentioned, the ZeroDev SDK is quite simple, so we'll be able to do all of this with nothing more than basically one method call. So let's start with execute user op. We can do a sync, and then in here, we can just set hash equal to await ECDSA provider dot send user operation. And then in here, just like a normal transaction, we can set the target. In my case, because I'm doing a burn transaction, I'll just set that as the dead address right there. We can set data to 0x and the value to ethers.utils.parse units and then 0.001 and ether. And that's it. That will request a signature, submit the paymaster data if we have that filled out in the ZeroDev dashboard, and so on. We can just close this out by doing notification.success and setting message to user operation successful. Then for the description, we can go ahead and pass in the hash. Okay, so let's move on to our second function, which is execute batch user ops. This will be very similar to the first function. Instead, we're going to be batching two different user operations together. In this case, two instances of the burn transaction that we just sent with execute user op. This means that it's only one signature and both of them will be sent through. So we can do execute batch user ops. And again, just one function call here. It's set hash equal to await ECDSA provider dot send user operation. Then we can just very simply take the object that we built up here, throw it in here, and do that twice. And that's it. We can now throw notification.success. Okay, so we're almost done. We just have one more function to make, which will be change owner, which of course we can set as change owner. And essentially what this will do is transfer ownership of the smart account that we generate to a different specified address. So again, we can set hash to ECDSA provider.change owner. And then we can just simply pass in the new owner address. In this case, I'm going to throw in one of my external walled addresses. Then that's it. We can just throw a notification.success, and there we go. That's it. So far, we've imported all of our base libraries, configured particle, initialized the smart account through ECDSA provider, and fetched all of the account info. We've handled the social login, sent a single user operation, sent a batch user operation, and changed the owner of the smart account. So we can just close this out now by opening up return and throwing in all of our JSX. I tend to skip this part, so let me go ahead and do that and come back in a minute. All right, so there we go. As you can see, it's pretty simple. We're just checking if user info is defined. If it's not, which indicates that a user is not logged in, then we throw the sign in with Google and sign in with Twitter buttons, which all they do is just pass in either Google or Twitter to our handle login function. Then when user info is defined, we display the name, smart account address, the balance in ETH, as well as all three of our buttons. So we can just close this out by doing export default and then app. Let's go ahead and run it and see if it worked. All right, so it looks like it worked. Let's give it a try. By signing in with Google, I can sign in with this account right here. And here we go. We have my smart account address, my balance in ETH, and our three buttons here. I've already gone ahead and funded this address, so let's give it a try and start with execute single user operation. We have our confirmation pop up right here. So we click on confirm, and there we go. User operation successful. Let's head over to the Go Early Explorer and check it out. And as you can see in here, we have 29 seconds ago, 0.001 ETH to this dead address right here. Okay, so now that we know that that works, let's go ahead and try execute batch user operations. We can go ahead and click on confirm, and there we go. We have our two transactions. Both are a burn of 0.001 ETH batched together right here. Okay, so let's try the final function, which is transfer ownership. This will transfer the ownership of this entire smart account to the address that we specified in the code. So I'll click on transfer ownership and we can confirm this right here. And as you can see right here, we have owner changed and looks like it worked. So now if I try to execute another user operation, then as you can see here, we get an error, invalid signature. If you'd like to learn more about Particle Network or even our newly announced Smart Wall as a service, then I'll have those links below. Additionally, if you'd like to give this application that we made today a try or any of our other web demos, then that link will also be included below.